Hello, this is John Cranner. This is my fourth video in the series about cracking and building movement. And as you can see, I'm kind of quite relaxed in my t-shirt. It's a very hot day on Saturday, the 20th of June. So I'm just about surviving up in the heat in my loft. So this video is even more into the nitty gritty of cracking. The last one was getting fairly gritty, talking about BRE Digest 251. So I'm going to be actually showing some examples of buildings I've seen. And I'm going to be talking about how to spot cracking due to foundation movement, which in essence, when I'm ever looking at cracking in a building, what I first do is to work out and to really throw out in a way whether it is a foundation movement cracking or not. We'll be going on through the slides that I show because I'll be doing another PowerPoint presentation in the middle bit. And there are four things that I have to, as far as I'm concerned, always have lined up and to be present all together to say and know that it is foundation movement. So we'll go through that. Whilst I'm on the subject, I've also got two other YouTube channels I haven't mentioned before. I've got another one that is called Conservation Structural Engineering, so it's allied in a way to this general structural engineering channel. And the other channel I've got is called STEM Ambassadors. Now, I don't know if any of you at all go into schools and talk about your job that has a technical background, but the STEM ambassador refers to science, technology, engineering, and mathematics. So I'll put links to those two channels there. So I've broken down the subject of cracking due to foundation movement into five different areas. The first one is now I've carefully said foundation movement and not said substance because the first bit is describing or defining the difference between subsidence and settlement. Okay, they're cracking or movement in the building, both due to foundation movement, and we're primarily concerned with subsidence. Both subsidence and settlement can cause cracking if part of the building moves and the rest doesn't, and that's what you normally get with subsidence. Settlement is generally the whole of the building moving down, but there can be cases if you've got a building on part good ground and part loose ground, say fill or whatever, so you get there with the settlement, part of the building moving and the other bit doesn't. So that's very much a case, and I'll say that kind of settlement wouldn't be covered by an insurance claim because it's something that should have been noted when the foundations were designed and put in. And then the second bit is looking at a typical diagram of cracking due to foundation movement, which I'll be referring to the book that I talked about in the second video I did on the reading list, which is the Peter Dickinson book, which I think is the best general book on cracking. And then I'll go through all these four factors I said before that have to be all there if it's going to be defined, as far as I'm concerned, as foundation movement. And then I say the real nitty gritty. This is typical cases of subsidence that I've come across. And I've only come across about 5 cases of subsidence in my 30 plus years. And the biggest one is one I got involved in before I became self-employed, and I was working for consultants in Cardiff. And then 2 cases of cracking foundation movement due to settlement. Welcome to the PowerPoint presentation point of the view. I've gone downstairs now so you can see a slightly different background. I've got my books behind me in my non-engineering library downstairs because it's absolutely boiling hot. It's really muggy upstairs. And the first slide here is talking about subsidence and settlement. I call it subsidence versus settlement. I realized when I looked back in my notes that I put in for all the list of videos that I planned, that I said I was going to do one video purely on substance and settlement, but there isn't really enough to make it worth doing a whole video. So I'm really just doing one slide here. Um, so settlement and subsidence both cause the same thing. It's the building moving downwards, but for different reasons. And as I say in the first sentence, it says settlement is a downward movement of the ground caused by the weight of the building applied through its foundations. So when you're building anything, be it a small house on clay or gravel foundations, or a very tall building that you realise that the shard is going to have a very large impact on the ground. So you make sure that the load of it goes down to a much more competent strata, i.e. you put it on piles and you take it down to rock. That whatever you put there, there is going to be compression of that layer. So all buildings settle. Generally, the settlement of the building is uniform. Okay, so you've got a uniform strata and you've got uniform loading as well. You get errors in that where you haven't done your proper site investigation and say that you didn't realize that your housing estate was on the landfill and partly not. And so those houses on the border line or settle more. And you then get cracking of those new buildings due to settlement because you've got uneven settlement. So it's not just subsidence that causes it. So the next slide, subsidence is a consequential down movement or part of it due to removal of the ground under the foundations. I was reading that before and it's not quite right, but it's almost there. I mean, say the removal of the ground could be due to mining subsidence or just the ground collapsing beneath it. It could be due to water washing away either a granular subsoil or the clay, but unlikely if it's clay. So you're losing ground there. If it is clay and water, what then happens then? It reduces the ground bearing capacity of the clay. So it doesn't exactly get washed away, but because it can't take as much load, then that part of the ground where the drains or the rainwater pipes are leaking will cause that part of the building to move down. And also, if you get trees close to a house where you've got highly shrinkable clay. Now, if you remember going back in the early videos, I showed you that map of the UK, where the highly shrinkable clays are on a line going from just north of the Wash, I think Rugby, Leicester area, and then taking a line down towards Bath and Bristol. So everything south and southeast of that has all these bands of highly shrinkable clay. But they generally aren't found elsewhere. So the third point is they're both vertical movement of the structure, as I said. But you get problems because generally with subsidence, you get just part settlement of the foundations, whereas the other part of the foundations don't move. So another way of looking at it is to say that settlement is what I expected and subsidence is unplanned. So if you've done all your sums and figures and calculations and done your site investigations correct, that the building that you put up there, be it big or small, should settle down uniformly and to about the amount you've expected. And subsidence is covered by insurance. I'm not sure excessive. Oh yes, excessive settlement is not. Well, yeah, it's both excessive settlement and where you get settlement happening in excess in one part of the building and not, because there is actually a building in America, I think it's Chicago somewhere, where they hadn't done their sums correctly and the whole building moved down about 8 inches, 200 mil. So they had to put in a step to go in at ground floor. On to the next slide. Um, this is a diagram taken from the book by Peter Dickinson I talked about, called Cracking Foundation Movement in Buildings, which, as I said, is probably the best book, general book on cracking in buildings, but is unfortunately out of print. So this shows a typical pattern of cracking where you've got subsidence cause. So you can see a diagonal pattern to the cracking. So you've got these cracks going up here, going across there. They are going from a narrow width to a much wider one at the top there. They go from the bottom to the top, and they will be visible both outside and inside. And those are the four conditions that you want to see if you have got cracking. If you haven't got all of them, generally something else is happening. And this is what I call, or I think Malcolm Holland called it a hand of God. So if you draw a line at right angles to that general line of cracking, which is there, and it's pointing downwards. Now, why I say it pointing downwards? Well, it's obvious that the hinge of that movement is there, and it's moving bigger there, so it can only be going downwards. There's no logical mechanism of movement where you could get the movement being upwards, unless you've got gravity working in reverse. And that is the opposite of subsidence, which is heave, which I've never come across, but does happen, and I've seen photos of it, and it can be more dramatic than subsidence cracking. So that's just a summary, as I said, of the four conditions for foundation movement, the four laws of foundation movement. So maximum crack's got to be 15 millimeters or bigger. The cracks go from the ground to eaves, and similarly it would do if there was heave. The cracks are diagonal. Now I say that with a certain amount of reserve because, I mean, as I said initially before the introduction, I haven't come across a lot of subsidence cracking here because basically I'm not in the southeast of England, and I would be called out to see a lot more. So I haven't got a very broad case of foundation cracking to show you, and they're not always diagonal in nature, but so that doesn't always have to be there, but it's of a diagonal type. So I'll go through that. We'll see, you see that more clearly when we look at the buildings. And what I think is really essential is that the cracks are visible both internally and externally. Because I don't know if you remember from a video I did before, there was cracking when I was talking about BRE Digest 251. I showed cracking to a garage where the cracks were on the outside skin, but there was absolutely nothing on the internal skin. So that the fact that they weren't there, and there was a kind of a diagonal crack, but they weren't big cracks, and they didn't go from the ground to eaves, so very little added up there, and so they weren't seen both internally and externally on that garage cracking. And this is an extract from the Peter Dickinson book that I referred to in the second video on reading material, called Cracking in Building Movement, which I've said it many times is the best book on cracking, but it's not possible to get in print, and you have to get it secondhand. And I just had a quick look, and the people are selling it for £100 each. But anyway, so talking about the cracking, so what we can see here is the cracking is going from the bottom up to the top. It increases in width from being narrow there and increasing in width. It is of a diagonal nature, so it's conforming with all the those 4 points I pointed out before.
it is visible both externally and internally, and certainly that crack, the size of the crack there, is certainly going to be larger than 15 millimeters. So those are all the conditions that you're looking for to satisfy it being due to foundation movement. And we've got on here the what Malcolm Holland calls the hand of God, as it points down in that direction. And that's the direction of movement that cracking is suggesting. It certainly can't be upwards, because there's no logical way that the top part of that building will move up. So gravity dictates, thanks to Newton and Einstein, that the bottom left-hand part of the building is moving down in that direction. Then the next extract here is the opposite movement, when you got heave, so like clay, when that doesn't have moisture being extracted from it. So when you remove a tree and it isn't taking the water out, and then it would rain and expand, and causing that the upward movement there, and a reversal. So you've got narrow cracks at the top and wider cracks at the bottom. This is, it's a photo that I remember Brian Clancy used when he was talking about his new book on subsidence that was done by the structural engineers, and he showed this photo here of a fairly boring and squat single-story extension. It looks all fine there until you take a step back and you see that the building has suffered a rather drastic movement down. I think it's due to a collapsed drain that ran underneath the building there. So that's obviously very dramatic ground movement, and there's no guesses in there as to how much where this building would be demolished and what was the eventual cause of that movement. Now, this is a housing estate in Brimau. Just before I left my consultant, just before I was made redundant by lovely Hell Crow, Cardiff, but in fact turned out to be one of the best things for me. We were called up to look at this pattern of cracking in the houses. Now you can see that the house here has got, well, you'll see it closer up further. It's just to kind of give an outward view of the area. It's high in Brimau, so it doesn't actually have a good view out, because a lot of Brimau is not very pretty. This little T-shaped housing estate called Pleasant View, because the view did look out onto the Coity hillside there, so it was quite pleasant. This is an aerial view taken relatively recently. The blue boxes here show where two pairs of semi-houses were. So the first photo was taken somewhere up about there, and you could just see the edge of that building there. And what's quite interesting about this is not only the amount of movement that did happen, but the pattern and shaping of the movement was very different to this house here, because if you go to the next slide, I've put on there, this was the suspected collapsed roadway. We think it was an iron ore roadway that went down the hillside in that direction and just collapsed there. There was a lot of rain the day before, or the few days before. People said it was running down the hillside behind and going down the road. So the house there just collapsed into that, and then it caused this house behind here to move towards it as it slipped in to the well, I say a hole. When they did the grouting for it after, they put lots of probes down in this area, which incidentally is now a playground. So they it was a local authority housing estate, and they thought, well, no one's going to want to live in a house. So they knocked it all down. They weren't going to rebuild it, because I think there's sort of the confidence of it being all repaired properly underground, what might not be that great. So they just did it as a kids' playground. So that's the front view of the house. So you have got horizontal cracking there and there and there. But there is, now when I was saying that not all these buildings just show diagonal cracking, so it doesn't show it going from the bottom there and all the way up to the top. So what has happened here, because you can see cracking going up there, well, and then it would go around the windows. That's what we call a free edge. So it goes along the top there, and then goes along that free edge, and then down that free edge there, and then across there. So basically, it's the middle of the house that's just given way. So you have got a diagonal crack there, but you do have mainly horizontal cracks there. But just looking at the pattern of cracking, you couldn't say it could be anything else but a foundation movement. The only other reason you might have that there, I think, pretty sure that there were cavity wall houses. If there was cavity wall expansion, you don't get that. And you don't get cracking both on the outside and on the inside. And they were big cracks there. We were monitoring those cracks and they were just increasing all the time. So it was a very quick decision that was made to demolish each house, and it was each pair was done. Actually, it's the hands of God. The blue arrows showing it pointing down, and just going back to the aerial view there. So we were looking at this house. The next slide we'll be looking at the house behind, which was this one. So that was slipping towards that hole there. So if we look at that cracking there, so the cracks are overall, if you look at the pattern, they are going diagonally from there up to there. They go from the bottom to the top. And so that the crack goes up there, it goes around that free edge, cracks up there and up there, and then goes around that free edge there, the free edge on the side of the window on the jamb, and then up to the top. So we've got all those patterns there for foundation cracking. And again, cracking seen both externally and internally. And just a few, that's again the hands of God, the blue arrows showing the movement towards the slip hole on the right hand side. Just photos inside showing the floor just dropping down, doorways distorting, just incredibly amount of movement that could only be due to the ground giving way, big gaps there. And then this next one was a house that had foundation movement. This was when I was self-employed, and it would have, I was 92, I think it would have been the late 90s, 97, 98, whatever. And the next slide we'll see, we'll be looking up the side of the house and up the back, up that side there. Can't quite see it, but there is, because my viewpoint is in the way there, but there is somebody standing there by the corner, I think, in the original photo. So this is at the side, at the back, and it was mainly due to, because if I go back, no, I can't go back. It was due to rainwater pipes going nowhere, really, just issuing out into the ground. So what we did basically, we formed a soakaway at the front and put drains to take all the rainwater pipes down there. So the next photo will be, I think, looking at detail in that area there. And you can see the downpipe there. So you can see the large gaps. So it's, again, it's not a diagonal crack, but movement that could only be caused by foundation. There'd be nothing else that could cause that type of movement. That is somewhere, I think, around the corner and further up, and just, large amount of movement. So actually, incidentally, I've got 3 pins there. So that's measuring both vertical movement and horizontal movement, because we've got a vertical crack in the brickwork there. So basically, the wall on the left is pulling down in a way, whilst the wall and the foundation to the right there is saying, well, I'm not moving, I'm just staying here. So that just gave way. So the amount of movement to cause that brick to split like that would be quite a bit. And then just evidence inside and if you look at the top of the door, you can see that it's been plain. So this had obviously been happening for a long time. It wasn't a sudden movement. So they hadn't done anything about it. So instead of looking to see, oh dear, this door's sticking, somebody come along and planed it, or perhaps even added on a bit at the top, I think, as one bit. So it must be, I think, this right-hand side dropping down. So yeah, rather than planing it, I think they added triangular bits to make it fit in. And a more recent place here. So what I'm doing here is showing you all the buildings that I've experienced significant foundation movement. And there aren't that many because we're jumping a good 20 years now, I think. So I didn't do many real, good foundation movements. This is a bungalow, of course, that was owned by the father of a local estate agent, Ian's father. Um, got no insurance on it. I think there's a pair here of them, and you can start to see it as some cracking there and cracking at the bottom there. I mean, that is diagonal in nature. The weird thing is that you normally think, well, the end wall, all full of bricks, he said informatively, with no window opening. It's a window openings that cause, weakness in the walls. If you tend to get cracking anyway, I think you can start to see some cracking up at the top there. It's going to show movement there, but basically what's happening was that the foundations were just put on very bad ground because we sunk a borehole down here, and it was all crap, which is structural engineers and geotechnical engineers technical term for not very good ground. So no cracking down there. So it decided to move all this down. I think the next slide might be a bit more deep. Yeah, so we're up in that corner. So you can see it's moved both down and across. Now, generally, when I see cracking much smaller nature than this in walls, what you do tend to see is hardly any movement in the mortar beds, but quite the movement, and it's just going to be 1 or 2 millimeters, which is due to the shrinkage and expansion, which was the type of cracking we saw in the previous video when I was just talking about, how you recorded things, and that was an expansion and contraction problem. This is just a whole magnitude bigger, so really big. So if you think that those mortar joints are going to be 10 mil, that movement there in the perp ends, so that movement horizontally is at least 20 mil, and I would say about 10 mil movement down there. So significant movement, and not due to thermal expansion. And there, the cracking at the bottom. So that's almost just movement out. So that was the odd thing. It was a combination of what was vertical movement, but here at the DPC it had moved out. So I think it was perhaps twisting. So as the foundation went down, it also twisted out like that, or the other way. And yeah, it was odd, and it just meant, well, not demolition of the house, demolition of that corner of the house, and propping of the roof, and then doing a zigzag, doing piling inside and outside, and doing a zigzag. And I don't know if I've put up the. Oh yeah, well, I haven't done here what the sketch I did, but that's the kind of the process. So you put it past each side of the wall, and you zigzag. I can't remember what I specified. It's either it's either a steel beam encased in concrete or a reinforced concrete beam there. So the load from the wall can then go to each pile there. And it worked quite well, and did the job. This is a more recent job. This was a house that was under, it was quarter protection, which was quite an interesting thing, where the person who owned it wasn't able to look after their own affairs. So the their relatives that then appointed the Court of Protection to do the work. So I was appointed by the solicitor, who, interestingly, had already had two previous structural engineers to look at it, saying it was due to this tree here, or these trees, causing subsidence. Now, the cracking was, and we'll see more detail, was all around this area. I don't know if they showed this, can't remember now, in the previous video about recording cracks to be able to digest 251. But anyway, it's a very busy elevation, and what's stopping getting a good appreciation of that? You know, normally you can just stand back and look at an elevation. You've got this garage in the way here. So what I had to do really to really see, you know, what was happening, and hopefully there will be that drawing, was to just take lots of measurements of all the windows and doors at ground floor, and then draw the elevation, because it was cracking in the middle there. Now there was just basically, I don't know how the structural engineers, so I'm damming down my own profession as to how the roots from this building could cause not this part of the building here with the bay window, which causes a weakness, large bay window, big lintel there, a window at the top there, but a nice big window here, no cracking at all around there. So it kind of the thing causing the damage, the roots go underneath, don't affect this part of the building, and affect just this bit. There was just no sense. What they also did was to do drain testing, you know, putting a camera down and see what they were like. And what was interesting was that I did actually get hold of somebody who used to live in that house, because I just did a Google search on this house, and the name, I nearly gave it away because I'm trying to be a bit circus, because it is actually up for sale at the moment, and at least two people have looked at it, and they've run away. And I found out that it was somebody now in Australia who had said, I'm living in that house. Does anybody know anything about it? Because my sister went past and said it was all forlorn, because the person who was under the Court of Protection was in a home. So it was all, and so I got in contact with him. He said, "Oh yeah, my dad was all constantly having to rod the drains." So that gave me a clue that there was a very low fall, and obviously a chance for water to escape. So that was the main reason that was causing it to happen. So we were a bit closer here. So the movement was in, I can't remember, up there somewhere. Will we get a bit closer? Oh, this is a back view. It was interesting. This was a photo that Jane, the person who used to live there, sent me, of how it was in the 1950s or 60s without that hideous greenhouse. No, oh, not a greenhouse. Conservatory. That's the word from him. Oh, you can see a bit closer there. But I did, I say, a pattern of all the openings there, that you, the little horrible little porchway there, and then I did a floor plan. So you see the cracking was along that line, and then there's also cracking upstairs between that one and that one. So you got cracking that line, and this was the line of the drain. So it was all in this area, so obviously causing damage. And that, you know, anything local to where the damage is, that's what's going to cause it. Right, so this is the diagram I did, taking the measurements of the doors, and just filled with, you know, this is how it was built. So it just seemed really odd that they would put in so many doors and windows, you know, just providing all points of weakness. So it's a kind of a diagonal cracking. You've got some, so I put two arrows here because I say, well, it's, you know, this downpipe here leading is causing, you know, movement down there, and it's causing that vaguely diagonal nature to it. But you see it where it's solid, that's where you see it outside, and where it's dotted, that's where you see it inside. And ditto there. So you got the main amount of movement in this area, and a small amount of movement over there. And again, where you have the drains, so there was leading under there and joining up and then going away down that direction. And right, so that was evidence of subsidence. cracking. This is two properties I was seen fairly recently. One in it's about 3 years ago, and the next one in 2 years ago, where it's just very dramatic as far as I can work out, movement that occurred to the building fairly soon after construction, and various reasons I'll go through that it hasn't happened again. So this porchway here should be level, and that string course should go level and along there, but it obviously doesn't. So what happened at some time is that this dividing wall, because this is number one on the end, just had a just was localized poor ground, and they just didn't go deep enough. So that just settled, and it settled gradually to an extent that because it was built from lime mortar, I'm pretty sure that these are all solid 9-inch walls, not cavity. So this is built from lime mortar. That gradual movement, it was able to take. So you can see here that that course here lines up with that. So that was originally up at that level. So the left-hand side of the corner has gone down. You can see there's been a bit of movement there that's probably been repointed up. But there's no large signs of cracking above there. And you can see that first floor is a bathroom windowsill has sloped down. And then these are the, and I took an estate agent around it because I thought, oh, this is a good way of showing it. He came into the hallway here, and the floor was sloping as well, just the same amount as that. And she got vertigo. She said, oh, I can't go in here any further. And on the right-hand side, you can see the window where we saw the dropped windowsill. So obviously a new, UPVC window being put in, but the opening, has got that amount of distortion as well. I did go in to see the owners about a year ago who I did survey, and they're quite happy because I said, well, it's okay, it has moved. It's and the other thing is there's no sign of any cracking in the paintwork around. So it's been repainted, God knows how many times since it was built 120 years ago or more. But there's no recent. So if there was current movement, you would see cracking opening up of all the joints in the timber work there. So there wasn't that. And then this is the second one. This was something I never really got deeply involved in, but I was given a report that was again done by another, a Cardiff based, the one before at that subsidence house was by a Cardiff engineer. I looked at the report. They said that this movement here, that you can see reflected on that side, was caused by the deflection of the timber beams, or timber breastwork is a kind of name, or timber lintels that support, because you've got bay windows here, so you've got to have something to support the stonework above. So you've got timber beams going across, and one each side. I can't go backwards and forwards easily, so I better choose my words carefully here. I basically disagreed with that. We'll see it in more detail, but you can see that, and they also mentioned about movement in this bay window. They said, oh, well, bay windows move. But what bay windows don't do is they don't move inwards like that. So you can see, not so much on that side there, but you can see on the left-hand side, that sill, that window sill, has sloped down back towards the building. Now, what happens generally with bay windows is that the footings for the house, there, and there, are done to a good depth because they know they've got to build all this wall on top of it, so they don't skimp on the footing there. But because they've only got a little bay, we don't need to dig down that deep, and they're often very poor ground that they're sat on, and you get settlement of the outer bit, so you get movement of the windowsill in the opposite direction. The other thing is that if it was due to movement of the windowsills, you'd get that side of the lintel above going down, and you'd get that side going down as a mirror there. But instead of it being mirrored in the middle there, it's mirrored in the about that axis, if anything. So my conclusion was that the piers had settled, and it did have a basement as well, so the whole thing, below had settled down, because that's the only thing that could cause that movement of that window, but that be straight, and ditto on that side. And you can see it. Now, the string course here of this stone does look perhaps as if you've got some settlement here, but if you look at the string course here, it goes straight along there, straight, and then it bumps up. But yet that windowsill doesn't slope back in, so it's all a bit weird. But my analysis, my conclusion was that these piers had settled down, and it wasn't due to the window lintels. So that's a so you can see the window, the bay. The head sill has the head lintel has moved down, and that has moved down towards the building. That's the inside. That's all straight. But of course, over the years, it gets new windows, and it gets all patched up with new finishes. So it's hard to tell. But there wasn't any evidence of any. Because I suppose they were thinking that water must have got in, but there wasn't any evidence of that happening. And just to show that buildings can collapse away, the first photo I showed it was when I first looked at it, and then nobody did anything about it, and then these coping stones that were on the ground here were up there. And interestingly, it had been auctioned off, and I did feel a bit of a snitch, but not really, because I thought, well, even more of that building could fall down, and that the driveway around it is all open. Anybody could walk off the street to it. So I did say to the building control department, we obviously know quite well about that, and actually the next day or the day after, they had put Harris fencing up around it to stop anybody from going.
So there's my video about cracking due to foundation movement. It's a bit longer than normal. So I find that it's approaching 3/4 an hour, just over 40 minutes. So hope you found that useful, and please share and subscribe, and put any comments that you want to in the comment box, believe it or not. Okay, thanks so much.